All right, so confidence intervals for means. So we just talked about the sampling distribution of the mean, and now we're going to use those ideas to come up with a confidence interval for an unknown population mean. Okay? Did I do this right? Yes. Z criticals, yes. All right, so confidence interval for a mean, we're going to, the center of our confidence interval is going to be our sample mean. Okay, so we're going to take a sample from a population and get a value, a sample mean. And that's a point estimate, right? That's one single point, and it's probably not going to be exactly the population mean, right? Because if we take a different sample of the same size from that population, we're going to get a different X bar. We take a third sample from that population, we're going to get a different number, right? So we're going to get all different numbers. So this is just one of those samples. So we take one sample, that's the center of our distribution. Then we're going to use something called a Z critical value and the standard error of the mean. Remember, we talked about the standard error was the standard deviation of the sampling distribution of X bar. So we're going to let this be the center of the confidence interval, and then we're going to go out in both directions from that center this many standard errors, okay, depending on how much confidence we want. Okay, and I'm going to show you a little table here in a minute of Z critical values, but the main confidence levels that we're going to be interested in, it doesn't have to be these three, it can be any confidence level we want, but generally we're going to use 90, 95, and 99% confidence intervals. So I'm going to show you the table again in a second. But the Z critical value for 90% confidence is going to be this many standard errors from the center of our confidence interval. If we want more confidence, then we have to widen the interval, right? Obviously, if I have a tiny interval, I can say, well, I'm so much confident that it's within this interval. But if I'm more confident, I have to include more values. More confidence means a wider confidence interval. So 90%, we're going out this many standard errors. For 95%, we go out almost 2 standard errors. And for 99% confidence, sometimes you'll see 2.575, sometimes you'll see 2.576. I'll give you either one. I'm going to use 2.576 here. That many standard errors. So let's look at that table for a second here to show you what I'm talking about. All right, I'll get rid of this. And this is the standard normal table. Remember, we talked about the standard normal table. 0 is in the middle. And what the Z critical values are the Z values that cut off for 90%. And we're going to use this Greek letter alpha to signify what we call a level of significance. And if it's 90% confidence, then the level of significance is 0.1. Think of 0.1 as being 10%, 90%, 10%, 100% total. 95% confidence, the alpha level is 0.05. 99% confidence, the level of significance is 0.01. But for now, we're just interested in the confidence levels. And again, we can choose any confidence level we want. We would just have to go to the standard normal table and find the appropriate Z values that cut off the middle 82% or 73%, whatever. But these are the three most common, so you'll tend to memorize these numbers. If you don't, you have your tables in front of you anyway. But for 90% confidence, if you look in the standard normal table, you will see 1.645 and negative 1.645 cut off the middle 90% of the standard normal distribution. For 95%, 1.96 is the number. 1.96 and negative 1.96 cut off the middle 95% of the distribution. And for 99%, 2.576. Again, some people will use 2.575. Some books doesn't really make too much of a difference. But I'm going to use 2.576 and negative 2.576. Notice that cuts off the middle 99% of the distribution. So that's where those Z critical values come from. Okay, so 90%, 95%, 99% associated with alpha levels of significance, 90% 0.1, 95% 0.05. And these numbers are going to come more into play when we talk about hypothesis tests. Right now, they don't really make a difference in our calculations, but just so we know in the future, in the near future, when we're talking about hypothesis tests. But right now, we just want to come up with a confidence interval. And let's look at a specific example here. Let's say we ask 114 store managers how long they have been at their jobs. Just a basic little question here. And we get a sample mean. So we ask those 114 store managers, and from that sample, from that one sample, we get a sample mean of 11.78 years. Okay. Now, very important here is when we talk about a confidence interval for mean, we're going to split it up into two conditions. One condition is that we know the population standard deviation, which is sort of an unreasonable thing. We're rarely going to know what that is, but in a classroom setting, many times we will be told what the population standard deviation is. If we're told what the population standard deviation is, then we're going to use this formula with this standard error. Okay, at the back of the board, I'll switch this in a minute and show you the other case. But for now, we're going to say we know what the population standard deviation is, and it's given to us in this example as 3.2 years. So we take a sample, one sample of store managers. We ask them how long have they been at their jobs. We get an average result out of those 114 of 11.78. We assume that we know the population standard deviation is 3.2. And our question is, find a 99% confidence interval for the unknown population mean, right? That's why we're doing this, because we don't know what the population mean is. We want to have an idea. This gives us what we call a point estimate, right? But it's not so reliable, right? It's just one sample. If we took another sample of 114, we would get a different number. So now we're going to try to come up with a range of values that's going to give us 99% confidence that the actual unknown population mean will be in that interval. We don't really know if it is, but we can get larger and larger levels of confidence. So we know sigma, we know x bar, we know n, and we know the z critical for 99%. We just looked at it, 2.576. So all we got to do is plug those numbers in, pretty easy stuff. So we look at the center of our confidence interval is the sample mean, 11.78, and then we go out in either direction this many standard errors of that sampling distribution of the mean that we talked about earlier. So we have z critical, our known standard deviation divided by the square root of the sample size. If you multiply these numbers together, you should get this number. So you have your center, plus and minus. This is called the margin of error. I should mention that. All right, so this is the center, and then we're going out this amount on either side. This amount is what's known as the margin of error. You'll see this all the time, especially these days with the election going on. Whenever you see a poll of what's going on in the election, they'll say it was a plus or minus 3 margin of error. That's what they're talking about. We got the center of the confidence interval, and then we have a margin of error that goes out on either side of that center. And so you calculate those endpoints, right? 11.78 minus this number gives you the lower endpoint of the confidence interval, and 11.78 plus this number gives you the upper limit of this confidence interval. So we can say with 99% confidence that the average time that these store managers have spent, all store managers, we just took a sample of 114, is between 11 years and 12 and a half years. Right? We can say that with a pretty high level of confidence. We don't know if it's true, but that's the best we can do statistically. Now notice, if we went to 90% confidence, the only thing that changes is the z critical. Right? Instead of 2.576 standard errors in our margin of error, we now are only going out 1.645 standard errors from the center of our interval. And notice if we do that, we're going to get a narrower interval, right? From 11.3 to 12.27 or so, right? Notice this is narrower than this one because the more confidence we put into our confidence interval, the more values we have to have in the interval. Makes sense, right? I can say, well, with 2% confidence, I can say it's between 11.7 and 11.8. It's not a lot of confidence, but it can be. All right. So confidence interval for a mean when sigma is known is this formula here. All right. We have an example, n x bar. We're told 99% confidence. That tells you what z-value to use. You plug that into the formula. You come up with your margin of error and your confidence interval. So this is your 99% confidence interval. This is your 90% confidence interval. All right, so now the second case is when we don't know what sigma is. When we don't know what sigma is, we have to use another technique. So now, what changes is because we don't know what sigma is, that kind of introduces another level of uncertainty, right? So instead of using the standard normal distribution and the z critical values to come up with our number of standard errors to go out from the center of our confidence interval, we're going to use something called a student's t distribution. I'm going to show you the table here in a second. So instead of a z critical value, we're using a t critical value. And the only difference, a student's t distribution is still a bell curve shape, but it has more area in the ends, in the tails. So it's kind of a normal distribution squashed down a little. So the probability in the center is a little less, and the probabilities on the ends are a little more. And it accounts for that extra level of uncertainty that is introduced when we don't know what this population standard deviation is. Right? It's basically a very similar formula. The center of the distribution is still going to be the sample mean that we get from our data. But now we're going to go out our margin of error again here. This is our margin of error. Okay. Margin of error. Now it involves a t critical value instead of a z critical value, and we have to use this s instead of sigma. So the s is the sample standard deviation, because that's all we have at this point, right? So we take a sample, we get a sample mean, and now we also get a sample standard deviation. On the other side of the board, we knew the population standard deviation. Here we don't, so we have to take the standard deviation of the sample that we're looking at, right? And that goes here where sigma was before, right? So very similar formula, but now we have to use these t critical values. So let's go look at these t critical values for a second and show you what I'm talking about. All right, so this is the t critical value table. I know it's not quite as clear as I'd like it to be, but I can't find a better table anywhere. If you can find a better table online somewhere, let me know. But anyway, this is the t distribution. And I didn't mention degrees of freedom, but we need to understand what a degree of freedom is here. So the degree of freedom is these numbers here on the left-hand side. So this comes from your table that I handed out earlier. Remember, this is the standard normal table that we've been using. Positive values, negative values. Then the next page are these t critical values. All right, so notice along the top we have different levels of confidence. 80%, 90%, 95, 98, 99, 99.8, 99.9. We are interested in this question for a 95% confidence interval, but whatever it is, you go to that column, whatever confidence level you're looking at, and the degree of freedom is going to be, the number for the degree of freedom is going to be one less than the sample size. All right? Now notice it goes 1 to 30, and then it jumps to 40, and then to 60, and to 120. So if your degree of freedom is between any of these numbers, the general rule is to go to the lesser number. So let's say you had 50 degrees of freedom, you would use the 40. Let's say you had 100 degrees of freedom, you would go back to the 60. Now, if it's like 119, you can use 120. I'll try to be, the questions I ask will generally be clear as to what degree of freedom to use, but if there's ever a doubt, use the lesser number. Okay. So then you look at the sample size, you take one away. Let's say the sample size is 15. So the degree of freedom would be 14. Whatever confidence level you want, you go across and you use that as your T critical. Now notice these are pretty close to the Z critical values. And as the sample size increases, the T distribution gets closer and closer to the standard normal. Notice that 120 for 90% is 1.66. And if you recall, for the Z critical, it was 1.645. So notice this bottom line here gives you the Z critical values for these confidence intervals. Okay? 1.645 for 90%, 1.96 for 95%, and for 99%, remember we used 2.575. They rounded that up to 2.58. But that's where these numbers are. Notice this is an infinity column. So as the sample size grows and gets larger and larger and larger, the T critical values will approach those Z critical values. All right, so this is the table that you're going to use to find the Z critical, the T critical values when you're using those to find a confidence interval. Okay, so let's look at an example. Let's say 10 cars are chosen of a new model, and we're measuring the miles per gallon on those 10 new cars. Now, 10 is a small number. So we have to assume, and this will be in the problem, it'll say assume the population is normal. As long as you see that, as long as it says assume the population is normal, you know that we can use these techniques, right? So even though the sample size is small, we're assuming the population is normal, so we can use our technique to find the confidence interval. So since n is 10, our degree of freedom is going to be 9, right? N minus 1. And we're given that the sample mean out of those 10 is 27.2, and the sample standard deviation is 1.8. So we have the sample mean, we have the sample standard deviation, we have the sample size. All we need is the T critical value. So you look up the T critical value in that table. Let's just go back and see that again. So we go to the T critical value under 9 degrees of freedom and over to 90% confident. We want 95%. Sorry, we're going to use a 95% confidence. So 95% column down to 9 degrees of freedom. And we see our T critical value there is 2.26. So that's the T critical value that we're going to use here. All right, so the mean is the center of the distribution, 27.2. This is our margin of error. We're going plus that margin of error and minus that margin of error. We looked up the T critical in the table for 95% confidence here and degree of freedom 9, and we found 2.26. Okay, so 95% confidence, 9 degrees of freedom gives us a T critical of 2.26. Now we just plug everything in, center of our confidence interval, plus and minus this many standard errors, S over the square root of n. If you get this number, you're going to see it's going to be this. You multiply the 2.26 times this and add and subtract to the center. You should get this 95% confidence interval for the unknown mean miles per gallon of all those new model cars, right? We don't know what this is, the population mean. That's why we're constructing a confidence interval to give us an idea of where it is. So now we can say with 95% confidence that that unknown mean is somewhere in this range of values, 25.9 to 28.5 or so. Okay, so confidence intervals for means. Next, we will do confidence intervals for proportions.